Hello and welcome everyone. We are going to be talking about building digital services that get to market quickly. And we know that launching a successful IIoT solution is complex, but the insights you're about to hear can make all the difference in accelerating your time to market. I'm Natalie Salter. I'm the Director of Marketing here at Cumulocity, and I'm going to be your moderator and host today. And I'm thrilled to introduce our digital panelists and leading the discussion on behalf of the team. And our little pivot is going to be Jorge Fernandez, who is an account manager here at Cumulocity. And he's worked extensively with our honored guest, and that is Steve Lewis, who's the CTO of Autonomy. And he's going to discuss some of the AI-driven distribution solutions that he's launched at Autonomy, and Paul Johnson, who's a senior manager of digital transformation at Edwards. And he'll talk a little bit about some of the insights that he has from their predictive maintenance programs. And so with that, I'm going to hand the stage over now to Jorge, who's going to lead the conversation.
Thanks, Natalie. Welcome, everyone. Today, we're talking about a core challenge in IoT, how to rapidly build and launch a digital service that actually delivers tangible value. I'm thrilled to be joined by two leaders who are doing exactly this: Steve Lewis, CTO of Autonomy, and Paul Johnson, Senior Manager of Digital Transformation at Edwards Vacuum. Let's start with, how did you initiate a project around industrial IoT? What led you here? And tell us a little bit about what you were looking to achieve. Steve.
Thanks, Jorge. At Autonomy, we've been working in the gas distribution space, and we've developed a kind of an end-to-end solution for optimizing the operation of gas networks. It's specifically optimizing pressures in the network, and this is really all driven by the drive towards energy transition and net zero. Our solution, we have electromechanical devices, telemetry equipment, bringing data from remote stations in the field to a central cloud platform, and an AI solution. So with regards to IoT, we're using a kind of an IoT architecture for the overall kind of concept, and Cumulocity is really the kind of glue in the middle of all this that holds it together. So Cumulocity brings data from devices in the field, makes it available to our AI applications, takes information back from the AI, controls the network accordingly. And the whole goal is to kind of optimize performance, reduce methane emissions, and allow for the injection of greener gases, all towards that kind of net zero goal.
Thanks, Steve. Paul, you work at Edwards on predictive maintenance and it's industry leading. Please tell us about who Edwards is in the digital solution that you've implemented so far, and how they translate to customer value.
So we're Edwards. We make vacuum systems. We're part of the Atlas Copco group. So our company overall is interested in how you move gas around, I suppose. Our holding company pushes gas out, and we try and suck gas away. Vacuum pumps are used in the semiconductor industry extensively. You want to be able to have a very controlled process. You want to remove impurities to make a semiconductor. So a huge amount of the processes are done with the semiconductor wafer exposed to vacuum. And one of the challenges is, if a vacuum pump fails while the customer's wafer is being processed, the process will fail. Typically, the wafer will have to be scrapped. And depending on the process and depending on the stage in manufacturing, a single wafer can be worth many tens of thousands of dollars. And if you're processing multiple wafers at once, a failure can lead to many millions of dollars of scrap product just because a vacuum pump fails. Now, vacuum pumps do fail over time. Part of semiconductor processing is depositing materials on a wafer, and some of that deposition will end up in the vacuum pump, and over time the vacuum pump will fail. customers have been dealing with that by just replacing the pumps really early. If you know a pump will last 6 months, you can swap it every 3 months, for example, but still you have unexpected failures. So we're using machine learning and artificial intelligence to try and predict failure.
Now that these solutions are live, how do you define the metrics of success? How do you know these products launches were a true success?
Is that to me?
Yes, sir.
Yeah, good question. So, I mean, I guess ultimately success is whether or not people will pay us for it. You know, we do a lot of trials at customer sites first. The semiconductor industry is extremely conservative, particularly with new technologies, actually. So we have to really prove ourselves before people will decide it's worth buying. So we measure success really by if you look at the number of failures you had on a single pump process combination over the previous 12 months, when we then install the predictive maintenance system, do you have significantly fewer unexpected failures once we've rolled out the predictive model? So, you know, we monitor things like hit rate, and we also look at things like false positives, you know, by assessing our pumps when we remove them. If the model says this pump's about to fail and we get it back to the service center and it's completely clean inside, we shouldn't have told you to replace the pump. Conversely, if we say this pump's about to fail and we get it back to the service center and there's evidence of failure impending, then obviously that's a success. So there's a metric like hit rate. It is really critical. But ultimately, at a macro level, the question is the customer having fewer unexpected failures in the presence of our system than they had when they didn't have our system?
How about you, Steve?
Well, part of our story is very similar to Paul's. You know, our customers work in a highly regulated industry. Safety is of utmost importance to them. So, you know, we don't get to sell anything until we've gone through successful field trials. Sometimes those field trials can last quite a long time. And we have to prove that the equipment's safe to install on the gas network before we can even get anywhere near the networks. But once we're on, really it's about measuring the reduction in pressure in the network, average pressure in the network. There is some variance across different territories, different customers about exactly what they're interested in. But in the UK, for example, the gas distribution networks are incentivized to minimize loss of gas and leakage. And there are established models that relate that to the average network pressures. So if we can demonstrate that we've reduced average network pressures over a period of time, then we're looking good. We did some work over last winter trialing our latest AI optimization algorithms. And in those trials, we were able to reduce pressures at the injection points by around 31%. And there are some standard calculations that can show that equates to a 16% reduction in methane emissions from the network over that time. So that's the kind of thing that we're looking for. We also have a kind of use case around the injection of alternative gas. At the moment, that's principally biomethane. So the customer is looking at, can I get more biomethane into my network relative to the natural gas sources? And so by looking at those metrics, again, we can establish some measure of success.
Thank you, Steve. Let's move on to the next phase of this conversation. Every successful launch has challenges. My focus is always on how do you de-risk the overall project. The key is focusing on where you genuinely differentiate and add value. So my question is, what were the biggest challenges associated with building the solution itself? Specifically, what were the key considerations for build versus buy when it came to the software side of things? Steve, can you comment on that?
Yeah, sure. So when
Just a
Good.
quick one from my side. I don't want to interrupt the discussion. It's very entertaining, very interesting. I just want to say I'm back on stage here. My technical challenges have been somehow managed. But let's continue, Jose. You do it with the discussion. Really like the discussion, especially thinking about how much value you generate from your projects and the real outcome you just described. It's quite exciting to hear.
Yeah, good to see you back on stage, Bernd. So
Yeah.
after the challenges. Okay, so on the subject of challenges, so Jorge asked me, what are the kind of challenges in this space and facing our project? So when we began, we had this vision, which was, okay, we want to be able to develop some kind of system that controls the gas network, can reduce the pressures, and ultimately do that under automated control from an AI machine learning kind of technology. So I had a blank piece of paper and suddenly discovered that there was an awful lot of technology to develop. So we thought maybe there's some hardware technology out there, some actuator technology, but in the end, it became clear that we were going to have to develop all of that ourselves. And in particular, the equipment we install on site, it has to be safe to operate in a hazardous atmosphere. So there could be oxygen, natural gas, methane mix in the environment, which is highly explosive. So you have to develop, in those circumstances, you have to develop your equipment to very rigorous standards in order to make sure you can't ignite the explosive mixture. So it was very clear early on that we were going to have this challenge just at the hardware level before we even got anywhere near the software. So that pushed us down, looking at the whole architecture. Where could we buy in technology as opposed to having to develop it ourselves? And it was clear that there were areas where we were just not going to be able to have a big software development team in the early days, and so we were looking for software platforms that would do the job. Cumulocity was one of the platforms we looked at and selected and stuck with. And I think that it's that kind of realization that you can build prototypes quickly, sometimes yourself with good technology that's available, but you need to be thinking about how you're going to scale it, how you're going to make it secure, robust, and in the end, the functionality you're trying to build might only be 20% of the problem of the work, and you've got that 80% lingering in the background that really has to be done. In our case, we were not going to be able to get the gas companies to allow us to put our systems on the market with prototype software. We needed something that was going to be solid, and so going for a buy approach for that part of the solution really was critical.
Thank you, Steve, for that. I really like your 80-20 rule here. Yeah, I think that's actually spot on. We see in a lot of projects that the non-functional part is often completely underestimated. I don't know how you feel about that, but scaling, security, high availability, operational challenges globally sometimes even, including China, that is completely underestimated. The focus is often just on the functional side, on the dashboards, on the visibility, or on the use case, but to operate an environment with real-time data and you rely on it, you need to change your processes. You actually sell services to your customer. You want to be in a situation where you can really have a solid technology partner. And often it is it's not really seen in the beginning of the project. So I really like your 80-20 rule. It's a strategic decision you did. And really think that's the right thing to do.
Yeah.
We really think about the non-functional way. It's even more important sometimes than the functional one in scaling the project.
And we'll probably shape your architecture more than the functionality does.
Yeah. And I think Paul, on your side with Edwards, what do you think? Or was your
I think the thing that sent us down the path of working with Cumulocity is we don't have enough software engineers, right? And I think if you speak to most,
that's an easy one.
yeah, I think most people who build software will say they don't have enough software engineers, even in the world where we're all excited about the various GPTs writing code for us. If you told most product people we could double the number of software engineers you'd have, they'd still ask for twice as many as that. So I think what you've got to do is figure out where can your developers add the most value? What do you aspire to be the best at? And for quite a long time, we'd been building our own data acquisition system. It started as I suppose a classic SCADA system. It would poll information from pumps, put them in a database, you could put it on a chart, and over time see how your pumps were behaving. And we got a team that had built that. But then, as we all know, over the last sort of 15 years, the deep learning revolutions got going. I always find it quite interesting that machine learning and artificial intelligence is kind of 75 years it is since Turing wrote, I propose to consider the question, can machines think? And it's taken until about 15 years ago for the compute horsepower to be there to actually be able to do something useful with it. But as it was apparent that we were going to be able to do useful things with this data that we've been acquiring for a long time, we had to start considering what are the bottlenecks in our current system and how can we best focus the software resource that we've got to be able to leverage that. And the conclusion you come to is we need to have our software team work on things that only we can know about. So I would contest, there'll be some other vacuum pump manufacturers would say differently, but I would contest that we know better about how data relates to a vacuum pump than anybody else in the world. I would contest that our software engineers understand how to get data from vacuum pumps, some of which are 20, 30 years old, better than anybody else in the world. I think our data scientists know better than anyone in the world how to use that data to be able to build predictive models. They're all things that I aspire for us to be the best at. I don't really care about us being the best at creating databases. I don't really care about us being the best at creating cloud infrastructure. I'm quite happy for Bernd and his team to aspire to be the best at that. And, I hope they do, because Cumulocity is a key partner for us. But I think specialization really matters. So we started down this journey of migrating from a platform which we built entirely ourselves towards bringing in, let's call it the backbone of our system, because I think Cumulocity can focus on that part of our overall system. And I think they can do that part of our overall system extraordinarily well. And it lets me, with the people we've got, focus on the things where we can add value that others can't.
Yeah, very, very good, Paul. And by the way, Jose, you are with customer success at Cumulocity, right? So do you have any additional comments to add here? What do you think about what's important strategic decision making when you enter a partnership like with us in Cumulocity? What is your view? Anything to add?
I think the best people who can speak to the partnership and how valuable we are to the companies we serve are people like Steve and Paul. But it's key to, especially at the beginning of the journey, to gain footing in the trust, working together. I mean, Steve and Paul have been around with us for a long time, and it's a treat to work together through the hard challenges and get to the other side of the tunnel, and that's where magic happens in the partnership, and where they see how we enable companies like Autonomy and Edgeworks to be the best at what they they're the best at.
No, I think that's a very important point. So just to also, Paul, to drill a bit on your comment, I think what is interesting is that we still have in our industries, especially in the industrial Internet of Things world, yeah, you have a lot of companies who used to work since tens and tens of years do vertical integration. They almost do everything themselves, right? Actually, I know even companies here, machinery companies in Germany and discrete manufacturing business, and they do even the screws. They even produce their own. You wouldn't imagine it, but I have seen that with my own eyes. They even develop and produce their own screws. So that's how vertically integrated they think. And suddenly, with the digital realm, with the digital approach, you suddenly need to learn how to partner, how to structure an ecosystem, how to work with hardware vendors, embedded engineers, software vendors, cloud platform and edge vendors. And that's a very different setup. So there's a lot of learning you have to do, and that's probably also Jose's comment on the projects. The way how we need to engage and learn is very different than when you do everything yourself as an engineering company, and you believe that's your key differentiation, doing everything yourself. In the digital world, that's not anymore the case. You have to understand that you have to strategically partner with companies like with Cumulocity in order to really focus, exactly what you mentioned, Paul, really focus on where you can make a difference, where you can differentiate. And that's on your understanding of the vacuum pumps and how you can add value on that. And it doesn't matter really, in a sense, how you operate your cloud or your edge environment and who is doing the database management in that sense. Yeah. So I really like that point, Paul. Yeah.
I think one of the other things that's interesting for me, Bernd, though, it's not just getting people to build things that we don't aspire to be really good at. It's interesting to be part of a wider community than trying to do everything yourself. Whenever I've been fortunate to attend some Cumulocity events, I hear things that other people are doing that otherwise I wouldn't. If I was trying to do all of this ourselves, we'd be far more in a closed box, and it would be our ideas that come out. I hear how other people are using Cumulocity, and it leads me to think, that's a pretty good idea. We should consider that. Or, Cumulocity and maybe developing part of the platform in a way that we haven't thought of. But when someone shows you something, your reaction can be quite visceral. So I found that really helpful as we've tried to build this whole system. We're learning an awful lot from what other people are doing, and quite a lot of that's coming through the partnership with Cumulocity.
Excellent. Yeah, Paul, that's the we sometimes at our customer advisory boards, like we had recently one in our office here in Düsseldorf, and we learned that joint learning experience when you hear others facing some challenges, overcoming them with protocols, hardware, connectivity. I mean, there's a lot of things you have to consider in a very complex industrial IoT project. And I actually like to use the word because I think I mentioned it last time as well, the unknown unknowns. And if you have a good community and ecosystem and you can share experiences, then you are more likely not to fall into the unknown unknowns, and you can actually gain insights from others in order to speed up your project and become faster successful. Yeah. So I really fully agree with that comment, Paul. In the let's say in the future, when we think about the regulatory environment, but also artificial intelligence becoming more and more important for all of us, right? What is the key complexity you would envision, or what is the key issue you're currently focusing on, and that more and more regulated environment, think about security, OT security, but also think about artificial intelligence in that way. Maybe Steve, you could start with here.
Sure. Yeah, so I mean, I think there's two interesting sort of sub themes there. That security is a massive thing for us. Historically, we've had to build security in from day one in our solution because of the industry we're working in and the implications. So we've taken very much a kind of systems end-to-end approach to security. We have complied with various standards, etc. But now, of course, we're seeing in Europe, we're seeing the Cyber Resilience Act, and I think this is going to be a game changer for a lot of companies. It's quite daunting. There's a lot of stuff to get into. And I think even for us, where we've been on a security journey for a long time from day one, and we actually, one of the selection criteria when we were looking around for platforms, security, a security story, a security posture was a big part of that. With Cyber Resilience Act, there's a kind of different change of emphasis, and there's a focus on individual products. And a lot more detail on individual products. So companies are going to who maybe previously weren't having to do a great deal in this area, now they're going to have a lot of work to do, and it's going to be basic security built into products, but also bill of materials, software bill of materials. It's going to be about vulnerability reporting and pretty onerous vulnerability reporting requirements 12 months from now. And another thing people need to look out for, and I think again there's an interesting kind of area to explore for us, certainly with you guys, with Cumulocity, and that is that with the Cyber Resilience Act, if you're building a physical product that connects to a platform, that platform is in scope of the Cyber Resilience Act for your aspects for your product, and understanding exactly how that's going to work out, where you're partnering. And what's the partner going to bring? This is part of the journey. We're very confident, but we've still got stuff to explore and discover around this part. And then the other part of what you asked around AI. So there's a regulatory story there as well, and I'm just scratching the surface. So for us, AI or machine learning technology is part of our solution. So we're developing our own capability in this area. And we have to, ultimately, we're building a system where machine learning will control a network, control a gas network, without necessarily a human in the loop, once the models are all trained, etc. So this has got to be robust. We have to take a lot of rigorous, measures to kind of prove that it's going to work, etc. And there are challenges there, and as I said, regulation will come into play on that. When it comes to the use of AI tools ourselves, we're currently being quite cautious about that. It's very early days, and we're going to have to probably get onto this track pretty soon. But again, because of our industry, we owe our customers a kind of responsibility to be very careful about the kind of the bringing in of that kind of technology in a kind of loose way. So we're very cautious right now about the use of coding tools, etc., AI-driven coding tools, and that kind of technology within the company. But it's coming.
Yeah, very good, very good. Yeah, I mean, if we think it's an amazing thought about autonomous operations, right? It's not just automation now. A lot of people start talking about autonomous operations, and this, of course, has a massive impact in terms of processes, quality assurance, and human interacting in that entire autonomous operation. So there's a lot of unknowns again here, what we have to master, and it will be probably a step-by-step approach with smaller parts you will automate or run on an autonomous way, and then you add additional capabilities and so on. And it has, of course, it could become potentially a real game changer in terms of operating systems, right? But I think we also have to ensure security and we need to rely on these environments. That is, I think there's a bit more time actually to go before we see that really happening in real operations.
I think if you have a process that you can operate at a certain level of efficiency and performance, but you can't go any further because there is not enough time for a human to perform the necessary planning, evaluation, analysis. AI comes into that and can give you something that can be a real game changer. And yeah, that's kind of where we are with the kind of control of the gas network.
Okay, very good, very good. Thank you, Steve. Moving forward to Paul on when you think about your company Edwards and your global scale. I mean, you literally have clients around the globe, right, with installed base and helping them to build efficiency in their operation with the predictive maintenance, for example, as a solution. So what is your take on regulatory environments and cybersecurity, especially considering the global scale? I mean, is there something else to consider than when you just focus on Europe in a sense?
Yeah, that's a good question. I think the regulatory thing's interesting. So if I start with, for example, the EU Data Act, obviously that's coming along, and it's something which will impact us for selling things into Europe. But in actual fact, that's not been that big of a problem for us, because the semiconductor industry's expectation for decades has been, if your machine produces data, it gets shared. Customers have been centrally capturing data in this industry basically forever. So we just continue doing that. The Cyber Resiliency Act is obviously something we need to make some changes. There's some procedural changes. Steve talked about the need for reporting and so on and so forth. Our expectation is that obviously we're going to have to do this in order to keep selling into Europe. But my belief is that it will become somewhat standard across the whole of the industry. I was in working in the US when some of the personal information changes came through the EU, and we made changes to our global product in the US because it's actually seemed like a good idea. I think some of the EU Data Act, the Cyber Resiliency Act, I think the EU is genuinely leading here, and they're going to introduce things that the rest of the world will look at and think, actually, that's a good idea. And either there will be legislation brought in various places in Asia, or global suppliers like us will just do the same thing that we do in Europe everywhere, because frankly, it makes sense. In terms of security and regulatory requirements and things like that, I find myself in a bit of an interesting position that I kind of wish our customers would let the security aspect of this be a problem for us. There is a paranoia in the semiconductor industry, which has been part of the industry almost since its inception. I think when the Traitorous 8 left Fairchild to start Intel and so on, there's been a paranoia built into the industry that under no circumstances should you let information leave your company. And in actual fact, that tends to go further to under no circumstances let information leave your building. So I'm acutely conscious of the fact I'm on a call talking about an IoT platform. A lot of our customers are pretty sensitive about providing an internet connection. So on the one hand, I don't have to worry quite so much about the Cyber Resilience Act, because if they don't let their devices be internet connected, it's something less of a problem. But then equally, I can't get the data out, and I can't do a lot of the really, really cool things with it. So I think we're probably a little bit behind people like Steve here, because we're trying to convince the industry, look, this is really secure. You should be sharing your data. Here's the benefits of using the cloud. The ironic thing is the semiconductor industry has, it's provided us with these astonishing tools that make the cloud possible, that make really secure connections possible. But despite having built the technology behind that, it's pretty sensitive to actually using it. So we've got a lot of persuading of customers before we worry a lot about some of the regulatory things that are coming along.
Thank you very much. Yes. So let me, before moving to some of the Q&A parts with Natalie, let me ask you one more question on just drilling down again on the AI topic, artificial intelligence topic, because we did hear from Steve already that there's useful applications emerging and interesting considerations. Anything else you want to add, Steve, on that topic? I mean, in terms of deploying it, machine learning, etc. Anything else which comes to your mind?
I mean, I think for us, different deployment models. We've looked at different approaches. Where does the machine learning sit? So we actually have built that into a sort of separate Amazon. A bit of infrastructure, and then we have integration with Cumulocity. So Cumulocity is, the data source, effectively having collected data from the networks. But then Cumulocity is also then pulling data from our Amazon environment, where we have the machine learning application, pulling the kind of new control profiles effectively, and then working out what to do with them and where to send them in the gas network. So it's kind of one of these best of both world things. From a security point of view, it's important that you have some flexible models in terms of how you can deploy. Again, different customers of different sizes with different security requirements are going to need a different thing. So, for example, where we currently, for our kind of primary platform at the moment, we use the kind of standard Cumulocity Cloud. We're also now looking at Edge as an alternative deployment model, and that will fit into a few different use cases, particularly around smaller gas operators in Europe who have a slightly different profile. Maybe they want to integrate that into some existing kind of broader SCADA environment. But security is always the prime driver in all of that. Other regulatory requirements around AI. So there's the AI Act in Europe, which we're just starting to look at. And the AI part of our product is only just commercially available. So, but it's in kind of active field trials at the moment. But this is one of the areas that we'll be looking to beef up, making sure that we can tick the relevant boxes, and we pitch the product in the right way with the right protections around it.
Yeah. No, thank you, Steve. By the way, I just learned the other day or a few days ago that there is some movement on the AI Act from the European Commission. So they are actually reviewing the AI Act and trying to simplify it so that they do not harm innovations and deployment scenarios, etc. So that might be good news to come, but let's see. So what's the outcome? At the moment, it's quite a heavy concept, which is based on a risk profile. So you would need to categorize yourself based on the risk profile, and then actually deploy various reporting and response times on that. So it's a bit of a heavy act, I have to say, at the moment. But with the news that it's under review, it might be actually simplified. Yeah. So let's say it actually, I got the information. It might be actually the next version should be still made available this year. So let's see. I don't know. At least I read that in some newspapers. Yeah. Thanks for that. So then going back to Paul, one more point on Paul for you specifically in terms of AI agents and and your industry, vacuum pumps, how do you foresee that? How can you make that available to your customers, and how do you drive additional benefit out of your relationships?
Yeah, so we see the agent as part of our overall service plans. So our goal is actually not to sell customers an AI agent; it's to sell them value-added service. The idea is that whereas customers used to have a break fix model, we're trying to convince customers that thanks to the technology that we've got, some of it being the predictive models, a better way to run your vacuum pumps is to sign up to us, and we will provide you with almost with vacuum as a service. So our product offering here isn't really to go to a customer and say, pay us X amount of money and you can have this AI agent running on this process. It's pay us X amount of money. We'll tell you when you need to replace your vacuum pumps. We'll provide the vacuum pump. We'll service the vacuum pump, and it'll all be rolled into one thing. So we're seeing it as I suppose, a bigger opportunity than just selling a piece of software. And then it will, the AI models will underpin some of that, because I think it's not just delivered. That allows us to not just deliver direct value to the customer, i.e., previously this pump would have failed, and now we tell you that it's not going to. We think when you get to certainly a regional scale, if I can get an indication from our predictive models within a country how many vacuum pumps I think are going to fail in, say, a month's time, I can feed that into my service channel. I can improve my spare parts availability. I can probably reduce the number of spare vacuum pumps I have in the loop. So I can reduce the amount of capital I've got tied up in spare vacuum pumps. So I think there's benefits that we can derive which customers can't, that will help us make the overall operating of vacuum as part of semiconductors more efficient. So yeah, we're looking at a transformation of the service business as opposed to just selling an AI agent.
Yes, I got it. Makes perfectly sense, and it's of course very challenging as well at the same time, right? Especially knowing that your clients love on-prem or edge deployments rather than a centralized cloud environment. Yeah. So, but thank you both, Steve, Paul, and also Jose for the great discussion and very valuable insights. I really, just let me point out two very important points. I really liked the comment about the knowing what you are best in where's your IP, where you want to differentiate in the market, and how to partner then, how to complement your offering and how to complement that in the partnering. And then the other comment was about the resources. You cannot do everything yourself. So you have to partner also, because you need to specialize your software engineering resources to an area where you can really make a differentiation. Yeah, I really like these points. So that's really two kind of points I feel very important for the audience. Back to you, Natalie. So I pass back to you with the Q&A part. Let's see what people are asking. Yeah.
All right. Well, we have a few questions coming in and a few that were submitted prior. So we'll start with Lloyd Townsend. Lloyd, thank you for your questions. I'm going to start with a question for Steve on the AI topic. In your opinion, Steve, at what point do we distinguish AI from ML, and how are these different in terms of the AI Act, in your opinion?
Thanks for the question, Lloyd. So I can't claim deep knowledge of the AI Act at this point, although I suspect I'm going to have to become that person. So I probably can't give you a complete answer, but clearly there's going to be a distinction between generative LLM type AI applications and more highly specialized constrained machine learning models. So I think I'm hoping that the answer will lie somewhere in that space. I suspect that there's probably a little bit more in the AI Act that means that a lot more work will still have to be done around the specialized area as well. I think what it means in practice is demonstrating checks and balances, mechanisms to protect unsafe outcomes if the ML gets the answer wrong, understand confidence levels and how the system operates where predictions are of low confidence, etc. But yeah, no doubt within the depths of the AI Act, there are going to be some difficult to navigate differentiators, but I don't have that expertise right now. Maybe with a simplified version that Bernd talked about, maybe that life will be a little easier on that one.
Paul, anything you want to add on that? Or?
No, I just want to thank Lloyd for asking that question to Stephen, not me, because I don't know.
Yeah.
It takes a community and it takes a village, which is again.
Yeah, there we go.
Good. So Paul, this one is for you. So with more and more predictive maintenance solutions coming to market, a lot of end users are also trying to adopt the various values that the data-driven models bring. But there still seems to be a hesitance to move ahead quicker, mostly because of the end users, and the businesses then are hindered to get the mindset change to act upon those different predictive alerts or what those alerts are telling you. So how are you approaching these situations? And what do you find assists that internal knowledge blocker so that you can really assess that end user trying to understand what the value of the benefits that you're getting from the alerts or the predictive monitoring solutions?
That's a really good question. I think you address it with compassion. I think there's a real human element behind this, to be honest with you. I mentioned earlier that a single vacuum failure can cost, depending on the process, it can cost anywhere up to $3 million of lost product from a single vacuum pump failing. So that's the prize, right? If we can stop that happening, you'll save $3 million. But if we get it wrong, we might cost $3 million, right? So if you're the person, our customer, who makes the decision, yes, I'm going to hand this decision making over to a predictive model. If it goes wrong and it costs $3 million, that person will probably get the blame, right? And it won't necessarily be warranted, and it won't necessarily change the fact that overall things are still better. That one failure will be a very real problem for a very real person. So I think we need to be understanding of why people are really conservative about decisions like this. We accept that it's going to be a fairly slow burn to get people convinced. We've built a pretty sophisticated simulator, so we can kind of replay data through our predictive models, and we can show this is what the model would have done. And I think over time we'll build confidence with the customers that yes, we would be better off using this versus not. But I don't think it's one of these areas where we can provide a mountain of data that supports the argument this is better. We can provide a mountain of data that supports that you will be financially better off doing this versus not. To be honest with you, we could get to a point where we might be prepared to give guarantees that you'll be financially better off, that will predict more failures than we'll miss. You could see a business model around that where we might pass the risk of that onto the reinsurance market and so on and so forth. So there's ways we could do that. But it doesn't change the fact that at the end of this, the person making the decision is a person whose priority, frankly, is getting their wage every month. And they make risk reward decisions around that. So I've seen too many technology transitions where technologists like myself and probably everyone else on this call can see this technology is obviously better. At a macro level, it is, but there's individuals involved in this, and I think we need to be sensitive of that, and I think we need to be prepared to take our time to really convince people so they do feel very comfortable with it.
Along those lines, when companies, when companies are starting their IIoT journey and they are bringing these new services to market, and being sensitive to their customers, what would you say is the most important piece of data that they should focus on collecting first? Or a common mistake that you see, companies making when they're trying to turn that into a new business?
I need to be a little bit careful here because I think some of the data that we gather up front leads to some of our predictive technology being better than our competition. I think properly understanding the problem in the first instance is important. I think going to the customer and giving them the confidence that we're not just a data team, right? We're not just trying to produce a black box that will tell them when something's going to fail or tell them how to run it. We need to go and show them we really understand vacuum technology. We really understand how vacuum technology relates to the semiconductor industry. We need them to understand that while, I don't understand the chemistry that's going on in an X reactor as well as my customers will do, but I've got a reasonable understanding of what's going on in a plasma in an X reactor and what that's going to do downstream into the vacuum system, right? So at the very start of this, we need to demonstrate to our customers, we really understand what your problem is here. We're not trying to sell you something that you didn't ask for. We're trying to help you solve a very tangible problem that you've got by working with the customers to get them to agree, yes, this is the problem we want you to focus on, then we can move forwards.
Really continuing on you being the experts in your domain, right? And leveraging the tools that are available to you to continue to do so. I think that's a really fair point. And Steve, when we were prepping for this call, you were talking about the ITIs, the security, the availability. And so we talk a lot about secure by design. And I'd love to kind of drill in on that a little bit about what that means to you, in a company like Autonomy, with things like the Cyber Resilience Act. How does a platform like Cumulocity help ensure that you adhere to those secure by design principles and those ITs?
Sure. So, Cumulocity is part of the overall solution that we offer to the market. It has to be secure. In a way, if there's an issue with one remote station, there's a certain amount of damage that an attacker could do. If they can penetrate the security and get access into the heart of the Cumulocity platform, then they've got access to all of the stations. So it's probably the most critical element from a security perspective. Mm-hmm. It kind of, when we first looked at Cumulocity, which was way back in 2016, even then, there was three of us, and I was worrying about quite a lot of it, and we knew we had to find something that was going to address those non-functional requirements, but particularly security. So we were very interested in. I'm trying to think of who it was, but one of your early customers, possibly Deutsche Telekom, had done a kind of comprehensive security assessment of the platform. The basic features that you already had working in place, obvious things like role-based access control, obviously encrypted communications, etc. All of these things factored in that early decision, and then over time, as we've developed the solution, other aspects, secure cloud operations that your teams operate, the tooling, you're protecting against denial of service attacks. It's all kind of standard stuff, but it all has to be there. Mm-hmm. Like I said before, if you're going to build it yourself, you have to build all that yourself as well. You're going to have to establish the security operations center. You're going to have to, there's so much that's got to be done. And it doesn't stop. It's an ever-changing set of goalposts with security. The the kind of the influence on the products itself is there to some extent. When we started, there were already quite a few pre-integrated communication devices, gateways, that sort of thing within the ecosystem that had, pre-integrated with Cumulocity, and that included the kind of secure onboarding of the devices, registration, etc. And we day one we didn't build our own telemetry unit. We just brought in some of that technology and then hooked that up to our custom hardware. So again, same thing, buy versus build. But that was a nice, closed, easy to understand. I think people underestimate understandability, and again, very important if you're getting on a platform, a fully comprehensive open set of documentation that you can tap into. And if you've got particular areas, maybe you've got from a past experience, there's a problem area that you've had before. You're choosing a new platform. You want to dive in and find out whether that platform has already thought of it and fixed it. And that was one of the nice things with, again, even in 2016 with the Cumulocity platform, when we were comparing it with other things. I didn't even have to sign up to anything and do a trial to get access to all the documentation. So it was very easy to find out some quite deep technical questions, including around security aspects, in order to support a decision, and that's still true today.
Great. Well, thank you all. That brings us to almost the top of the hour and the end of this Q&A session. I found this session to be very insightful, and Jorge, thank you for jumping in and lending your expertise as well. Paul, Steve, Bernd, thank you for your time and sharing your not only your real world successes and your challenges, but I'm sure that the community also really values your expertise, and as being practitioners that have successfully deployed a platform with these kinds of considerations. I do want to just quickly say that if you're looking for some additional information about Paul or Steve's story, you can find their case studies on the Docs tab of the portal here. And if there's anything that we discussed today, particularly around de-risking your solutions, or you want to take a look at what a platform like Cumulocity might do for you, we'd love to get in touch. You can also click the request demo link and we will schedule a customized demo. The recording will be sent to you, and we really hope to see you again on a future session. So Paul, Steve, Jorge, Bernd, again, thank you for your participation. And for those of you attending, hope you have a wonderful day. Take care.
Thank you all. Thanks. Bye-bye.